All right, number 7, the last set of notes for this unit. Let's go ahead and put a little number 7 on it. So these are notes on line of best fit. All of the math we've done up to this point combines onto this one lesson. So know that none of it, or there's only one piece of new information, and everything else is stuff you've already done. We're just combining it all together. So first of all, line of best fits take place on scatter plots. And what a scatter plot is a coordinate plane that has tons of dots on it, but they're all scattered. They're like everywhere. They don't follow a certain pattern. So a coordinate plane with the points not following a strict pattern. And it's usually real data. So usually scatter plots are filled with real data. And the thing about real life is real life doesn't really follow a very strict pattern. It's usually all over the place. Sometimes it follows a tiny pattern, but not like a super strict one. So I'm going to show you an example. I'm going to erase this. This is a scatter plot. So they sort of have a trend, right? They sort of start down here and work their way up-ish, but they're not following a very strict, straight line type of pattern. So this is very real-life information because, for example, a beach determined the temperature on different days and charted how many visitors showed up to see if there's a correlation. So the data is plotted on the scatter graph below. So the X is how hot it is outside. What's the temperature? And the Y is how many people showed up to the beach. So obviously it doesn't follow a strict pattern because, like, for example, there's one day where it was 86, because between 84 and 88 is 86. There's one day where it's 86 degrees and there's 375 people, and then a different day where it's the same temperature, but there were some more people. There's closer to like 425 people. So first of all, when there's a scatter plot, you're going to ask yourself, how many pieces of data are there? So if I count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 pieces of data we have. And then the second thing I can ask myself is, what conclusions can I draw in general? Like, for example, I know that in general, as it gets hotter, these dots are going up. The amount of people is getting higher, right? So in general, it starts low and then gets higher the hotter it gets. So I can draw the conclusion that the hotter it is, in general, there will be more people at the beach. Okay. But what I couldn't tell you was, so next week I read it's going to be 105 degrees. I wonder how many people I can expect at my beach. It's like right now I can't make that guess. However, if I make a line of best fit, I can use that line to make a guess, and I can predict things. So here's how we use a scatter plot to predict. Step 1, you're going to make a line of best fit. Step 2, we're going to find the equation of the line. In this math, the finding the equation of the line, we've done that time and time again so far. So we're going to be really good at that part. In step 3, we're going to use the line, or use the equation we just found. Use the equation to predict. So those are our 3 steps. We're going to do them one by one together in an example on the back. So go ahead and turn it over. So there are a couple rules for drawing a line of best fit. first of all, rule number 1 is it must follow the trend of data. Which means, right now when I say the word trend, it starts kind of low and then goes up as time goes on. So a line like this does not do what my data does. My data does not start up here and then go down. So it's not following what the data is doing. So this would be a very, very bad line of best fit. It doesn't fit it at all. But then step 2, like for example, let's say I said, well, it starts down here and goes up like this. So this is following the trend, but it's still a bad line of best fit so far. Because, so don't copy it yet. It's still a bad line of best fit because there's rule number 2. And rule number 2 says an equal amount of dots on each side of the line. Okay, so there's 11 dots. Remember we counted them? So, and you're going to try to make your line very close to mine. I've done this a couple times, so I know which 2 dots I'm going to use. But in general, I like to take a ruler and like place it and like count and be like, oh, that's a good one. I'm going to connect those 2 dots. So the one that works really, really well for this one connects this dot right here to this dot up here. So I'm going to try to get that. So it does what the data does. It starts down here and then goes up. And if you count above the line, there's 1, 2, 3, 4 that aren't on this line. And then beneath it, there's 1, 2, 3, 4. So it has an equal amount. If it's like 4 and 5, that's fine too. As long as it's only off by 1. That could be like 2 and 3 or 3 and 4, but it can't be like 4 and 6 because then you should meet at the middle and have 5 on each side if that were to happen. So this is a good line of best fit. And so here's the thing. You can draw a line of best fit that's different than mine. It didn't have to go through those 2 dots. So we can have different lines of best fits and that's okay. So everyone's going to have different answers. It's, you know, but in this case, let's make sure that we have the same line. So for our notes, that they're the same. But on your worksheets, you can make any line you want as long as it follows these 2 rules. So then I have to pick 2 points. Again, on your worksheet, when you're doing it by yourself, you can pick any points as long as they're on the line. They have to be on the line. Like I cannot pick this point. It's not on my line. But on my line, I went through this point and that point. So this point, the x, is between 80 and 84. So the x is 82. And then the y, this is 75 and that's 150. This looks like it's about at 100. Note that I just guessed that. I just guessed that I think it's at 100. You might have guessed that it was 90. It doesn't matter. As long as you're close, you're going to be counted as right. Okay? Okay, for my second point, if I look down to my x, that's between 92 and 96, so that's 94. And then the y is a perfect cross at 600, so I don't have to guess that one. So those are going to be the 2 points we're using right now. All right, so I'm going to erase everything and scroll, but I'm going to rewrite my points at the top so I don't lose them. So now that I have 2 points that was on my line of best fit, I do everything we've done in the past. Remember to find the equation of a line with 2 known points. First, use the formula for slope, which is y2 minus y1 over x2 minus x1. So you label your point xy, xy. We'll call this the first one and this the second one. So to do my slope, I do 600 minus 100 over 94 minus 82 equals 500 over 12. So in my calculator, if I do 500 divided by 12, I would get 41.66 repeating. So that's my slope, that's my m. And then to find my b, I take it, y equals my slope, which is 41.66, x plus b. I take either point, it doesn't matter which one and plug it in. I'm going to do the first one. So the y for my first one's 100, equals 41.66 times x, which is 82, plus b. So 100 equals, calculator, 41.66 times 82 is 3,416.12 plus b. To solve for x, I minus that number away. Those cancel. And 100 minus that is b is going to be negative 3,316.12. So the equation for my line of best fit, the one I made, remember on your worksheet you're allowed to make different ones. But for this one, it's y equals, the slope was 41.66 x, and b was negative 3,316.12. So this is the equation of my line. All right. I'm going to erase it. I'm going to rewrite the equation at the top so that I have it. Let's see. Y equals 41.66 x minus 3316.12. And finally, I'm going to use the equation of my line to predict. And this is step 3. So I could say, how could we use the equation to predict how many visitors the beach would have if it's 100 degrees outside? Degrees, if you remember our graph, was x, right? So what we do is we take the equation, y equals 41.66, but instead of x, I'm going to plug in the 100 they asked me to plug in. And if I put that in a calculator, exactly how it is, 41.66 parentheses 100 minus 3,316.12, I find out that there would be 849.88 visitors at the beach. Here's the thing, they're people. You cannot have point person. So you cannot have 849.88 of a person, which means I have to round. 0.88 is closer, like think 88 cents, that's closer to $1 than it is to no dollar. So I'm gonna round it up. I'm gonna say it's about, remember about is that little symbol with it's an equal sign with the curves. It's about 850 visitors. Remember I asked you a word question. I said how many visitors would be there. So you need to tell me that that's 850 visitors. All right, another way you can use to predict is they can ask you, how would we use the equations to predict how hot it is outside if the beach had 500 visitors. So this time what I'm telling you is that there's 500 visitors. Visitors was our y, which means in my equation, instead of y, I'm going to write 500 equals 41.66x minus 3,316.12, right? They're asking how hot it is. They want you to tell me what x is, so I need to solve for x. So to solve for x, I add this to get 3,816.12. And to get rid of the number in front of x, you divide it away. To find out, in this case, x would equal 91.6. Remember, I'm asking how hot it is. Again, you don't have 0.6 of a degree. So I'm going to round up and say it's about 92 degrees outside if there's 500 people at the beach. And so what this does is it takes a real life situation like the beach and the temperature and the scatter plot, and it lets you create a line that you can use to estimate things that might happen in real life.